I would like to thank the invitation by American Chamber for me to make the presentation on the topic entitled Sports Nutrition, Improving Immunity and Healthy Aging. My lecture comes into three parts. The first, I would like to talk about the role of bone marrow-derived immune cell on aging. And I will also talk about the exercise mobilize bone marrow stem cell into blood and tissues. This is important for rejuvenation of the muscle tissues. And I would also talk about the cell renewal by nutritional support. And the reason this is important is because when you are proliferating cells, you need the immediate nutrient supply to maximize the cell proliferation and shorten the inflammation. Okay, the first I would like to bring the rationale linking exercise, immunity, and nutrition. It's very important to know that human body are multicellular. So if you look at ourselves, we have a lot of living cells. And the average cell age, not how long you live, determine use level and fitness of a human body. If you can control cell death and regeneration by will to maintain a static functional weight, the use is sustainable. And this has something to do with the immune power. And one of the reasons that the life is not sustainable is because of the immune system are declining with age. And I will talk about that later with some of the evidence. The exercise eliminates age cell population in a Darwinian nature selection fashion, mediated by brief inflammation. And as you might already know, that inflammation is the behavior of immune cell. Okay, so you don't want to regard as inflammation as a bad thing. Inflammation is simply an immune response which help you to eliminate the senescent cell in your body. Okay, finally, I would also give you very important things that the post-exercise cell regeneration requires various fast digestible nutrients. So you know that after exercise, the senescent cell are dying, and we need to regenerate the cell. And we need to know what kind of nutrients are required for the cell regeneration. And therefore, you can have fast recovery from inflammation. Okay. Now this is the important background for everybody. We all understand that human body are multicellular, okay? And therefore, if you look at every individual cell in human body, they are mostly short-lived. 80% of the cell in human body has the longevity less than 4 months, okay? So you understand that we have young cell, middle-aged cell, and old cell in our body. And we also understand that the cell aging, death, and regeneration are continuously occurring in our body. And the body weight of the human is determined by a balance of cell death and cell regeneration. That means if you look at yourself in the past 10 years, if your body weight are gradually increasing, that means the rate of cell regeneration is larger than the cell death. Okay, and you also understand that at the end of the life, you witness weight loss, right? And that weight loss is simply because of the rate of cell death is greater than cell regeneration. Okay, and it's very important to know that the immune system are responsible for senescent cell clearance in your body. So we have the innate mechanism to make ourselves young, not very, okay. If you look at the cell, that most of the cells in our body are less than 4 months of the age, but most of the people have the longevity more than 70 years. So that has something to do with the immune system that is constantly clearing the senescent cell in our body and triggers regeneration mechanism. Okay, then we come to the question. In our body, we have the cell are aging and dying and regenerating. So what causes cell aging in our life? The first, of course, you understand time, right? And you also understand growth is another factor, which is also very important. Growth means the cell size getting bigger and bigger, and you will eventually reach a state that becoming thermodynamically unfavorable, and you will eventually becoming unhealthy. That would attract the immune system to kill those cells when the healthy condition cannot sustain. Okay, infection is another thing. Okay, infection and the physical damage of the cell, it will cause the host cell becoming unhealthy, and those cells can also enter in senescence. And when the cell entering the senescence, those cells would be recognized by the immune system and will be killed. Okay, radiation and some other factors are also important for the cell aging. Okay, here I would like to present a very simple experiment that has been done in 1979, which is very classical. The experiment is very simple. They take out the phagocyte as a part of the immune system in the blood. And they also isolate the human red blood cell into young and old fraction. So when those phagocytes are mixed with the old red blood cell, there will be 75% cell clearance per hour. Okay. However, if you put the young cells together with the phagocyte, the cell clearance is only 5%. So this experiment is giving us the knowledge that in a normal human body, we do have the mechanism to check whether the cells are old or young. And they can selectively eliminate the senescent unhealthy cell in our body. And that is the reason why that most of the cells in our body are short-lived. It's less than 4 months of age. However, the human body can sustain for, sometimes you can sustain for more than 100 years. So the immune system plays important role. And if you understand in our body, we have the immune system to keep our body young, then why we cannot survive forever? One of the main reasons is because the immune power in our body are limited. Okay, you know that the immune cells are produced in the bone, right? And you see bone all over our body, and it's taking care of the tissues surrounding the bone, right? And you will find that not enough bone relative to the body are one of the main cause that the tissues get aged. Because if you cannot constantly eliminate the senescent cell in the tissues and regenerate the tissues by the bone marrow cell, then it is very difficult to make the tissues young, okay? And the bone producing immune cell, and the immune cell is very important for elimination of the senescent cell. And bone also produce the stem cell, and that is very important for repopulating the cell population in tissues. Okay, so both mechanisms in the bone guarantee the tissues rejuvenation and maintain use of the tissues. Sometimes when you have too many senescent cells in the body, that normally when you have huge population of the cell. Okay, so when you are young, when you are kids, the body weight only 30 kilograms. Okay, and you see that the total number of the senescent cell in the body is small, right? But when you grow into 60 kilograms, the cell number from 1 trillion becoming 2 trillions of cells, then the absolute senescent cell number in the body becoming huge. And therefore, the immune system is going to trap into the tissues that has the senescent cell. Okay, so when my immune system are trapped into the tissues that has the senescent cell, and it has no spared immune system to take care of the other tissues or other challenge. And therefore you can see that the wound healing capability and the recovery from the infection becoming longer time for those people who has larger body weight. Okay, so that explains the reason why if you have the COVID-19 infection, the young people has very low symptoms, and most of the people die are having body weight greater than normal, and they typically have the metabolic syndrome. Okay, and they are older people. Okay, and another situation that is also exhausting the immune resource and accelerating aging is inhibiting cell proliferation. And that typically occur when you have the chemotherapy and radiation. Okay, and another situation is when you have persistent challenge that we normally call chronic inflammation. Okay, so that is also related to the total cell number in your body. Okay, so we understand that immune system and the stem cell are important for rejuvenating our human tissues, and those cells are actually produced from the bone. Okay, so the bone are very important cell proliferation organ. So you regenerate the CD34 cell. The CD34 cell is also called HSC, hematopoietic stem cell, which is the common ancestor of immune cell and tissue stem cell. Okay, and you understand the immune cell can recognize unhealthy cell, senescent cell in our body, and clear those cells by free radical. Okay, and those free radical is going to attract the tissue stem cell localized to the area. So you know that the CD34 cell is going to develop into all kinds of specialized stem cell, including endothelial cell, that is important for regenerating the capillary, muscle, adipose tissues, myelofibrosis, bone. Okay, so all these cells are also originated from the CD34 positive cell. So having enough bone to taking care of the surrounding tissues are very important. So we don't want to have the tissues to bone ratio too high. So if you have big tissues to be taken care of by the bone, then it's very difficult to guarantee that all cells in the tissues can be rejuvenated in time. Okay. Here is another study that we have conducted in the past 7 years. That it's a very simple study. We raised the animal from the beginning of the life until the end of the life, and those animals has the same genetics. Okay, so when they have the same genetics, you look at their longevity, they still have different longevity. Okay. Then we divide those animals into 5 different groups according to their lifespan. Okay, so we have 5 different lines here, and we have black line, lifespan 1. So that is a short-lived group. And we have the long-lived group, lifespan 5. Okay, the blue lines. If you look at this graph, this is the percent bone mass. Okay, the percent bone mass represent the relative bone divided by the body weight in percentage. If you look at the long-lived and short-lived group, the major difference is the percent bone mass. Okay, and you can see that the short-lived group, the black line, are the one has relatively lower percent bone mass relative to their body. And the long-lived group has about greater than 30% of the bone to body ratio. However, this ratio are declining with age. And this declining is related to the increased body mass. If you look at this is the body weight. You can see that by 18 months, the body weight increases, and therefore you see the percent bone mass becoming declined. Okay, despite the absolute bone mass are actually increasing during the period, but the relative bone mass are declining. So you understand that if you don't have enough bone, even you have a bigger bone, but relatively you have less bone mass in percentage, then it's very difficult to keep the tissues younger, and therefore you can have the aging by the last quarter of the life. So you can see how important the bone is, and you want to regard the bone as the bone marrow cell producing organ, and that is where the immune system is originated. Okay, now we find a way to make the bone release the bone marrow cell into the circulation and tissues. Okay, and you can see that aerobic exercise and resistance exercise can increase the CD34 cell into the circulation. So this is during exercise. You can see that the bone marrow cell almost doubled in circulation, but it declined immediately after exercise, after aerobic exercise. And you also notice that this is only valid for high intensity exercise. If you have the exercise intensity, only 30% of your work rate, peak work rate, that is moderate intensity, then you don't see the increased bone marrow cells in blood. Okay. And if you look at the resistant exercise, you know that resistant exercise is a muscle damaging exercise. And you can see that the bone marrow cell increase immediately after exercise and also decline thereafter. But if you have high intensity, 80% 1 RM, then this increase can sustain for 6 hours and then decline by 24 hours. So from here, you see exercise can increase the bone marrow cells in the blood, but this increase are very short period, and it will be declined by 24 hours. Then we ask the question, are circulating bone marrow stem cells seated in muscle for tissues regeneration after exercise 24 hours later? Then we have conducted experiment by the muscle biopsy. So the muscle of the human young men, they have the biopsy 24 hours after exercise. And you can see that the CD34 cells, the bone marrow cell, almost doubled 24 hours after exercise. Okay, this is the muscle cross-section. You see the brown color, that is the CD34 positive cells. So you can see those stem cells are surrounding the myofiber and is ready for use to regenerate the myofiber. Okay, these bone marrow cells are the common origin of both satellite cell and the vascular endothelial cell. We know satellite cells are the muscle stem cell, and the vascular endothelial cells are they are also the cell for the capillary. Okay, so you can see the vascular endothelial cell and the muscle satellite cell, they are interconvertible. Okay, so if you have a more muscle damage, then those CD34 cell is going to develop into the muscle satellite cell more. But if you have more endothelial cell damage, then the CD34 cell is going to use to regenerate the capillary. Okay, so because we have the bone marrow cells and we have enough bone, so we don't worry about challenge because we can always recover from the damage. So you can see how important the bone and the immune cell is. Okay, then we come to the question. After exercise, we are going to have huge cell regeneration. And the cell proliferation require nutrient. Then we ask the question. Regenerate the cell, amino acid and glucose, which one are more important? So here is the answer. Amino acid rather than glucose account for the majority of cell mass in proliferating mammalian cell. So that means after exercise, if you have enough amino acid to supply the challenged muscle, you can maximize the cell proliferation. Okay, so the first I would like to show you that the exercise is going to kill a lot of cells, and they are mostly senescent cells in the skeletal muscle. Okay, this is the muscle cross section. Okay, you can see the myofiber. You can see at the age of 20 to 25, you can see the brown color, that is senescent cells. Okay, and immediately after exercise, you see this brown cell decrease by almost cut into half. Okay, and these low senescent cells can persist for 48 hours. So that means if you doing a squat, then the muscle is going to be has less senescent cells, and that condition can persist for 48 hours. And then we ask the question, if you do squat and if you have the nutritional supplement, high protein and low protein, does it affect to the inflammation? Okay, this is the inflammation marker. That is the leukocyte infiltration. And clearly you can see that post-exercise, you have a more cell infiltration, right? Leukocyte infiltration. And the reason is the leukocyte is going to eliminate unhealthy cell in your muscle tissues, okay? And when you have leukocyte in the tissues, that means the inflammation is still there, okay? And when you have the high protein, then you can see relatively lower leukocyte infiltration. So that also indicates that your inflammation are resolved at faster pace. Okay, and if you ask the question, what kind of leukocyte is there? We measure the phagocyte, CD36, CD68 macrophage. And you can see that if you have the high protein, then even you have relatively higher macrophage, but you are lower 48 hours later. But when you have the low protein, then the phagocyte stay in your tissues for longer period. Okay. So this is another study that has been done in obese women. It's published at almost the same months of our study. And you can see that the myofiber, you can see the blue, you can see the brown color. The brown color is the P16 positive cells. So you can see that in the older woman, the senescent cells surrounding the myofiber there are some senescent cell. And you can see this. This is following 5 months of the resistance exercise plus caloric restriction. You can also see the senescent cell number decreased. Okay, so now we can conclude that this resistant exercise can lower the senescent cells in your muscle. So it demonstrates that resistant exercise can rejuvenate the human muscle tissues. Okay, so I'm going to state the conflict of interest statement for the following study. Is involved with the product that is sold in New Leaf Science, Taiwan and US. Okay, this study we are using a commercial product that is actually an immunostimulant extracted from ginseng. Okay, and if you have the immunostimulant ingestion 1 hour before exercise, then you can see that 3 hours after exercise, if you look at this is the muscle tissues before exercise, you see a lot of brown color. Okay, that is the senescent cell marker. We call SA beta galactosidase. Okay, and this is immediately after exercise. You see the muscle become very clean and it's almost none of the senescent cell. And 3 hours later is the same. Okay, so this demonstrates that if you have the moderate intensity of aerobic exercise, it doesn't really kill the senescent cell like we have shown at high intensity exercise. But if you have the immunostimulant, even you are doing the moderate intensity aerobic exercise, you can still see the senescent cell number decreases. Okay, so this is mediated by the immune function. So from here, we also see that the immune system are very important for clearance of the senescent cell in human body. Okay, and this is resistant exercise. You can see the resistance exercise can lower the senescent cells, and it's more effective. Okay, so when your body are rejuvenating, then the body are young, and has the higher growth potential. And that is the foundation that resistant exercise promote the growth of the muscle, simply because of the muscle are younger and has better growth potential, okay? And if you take the RG1, which is the immunostimulant, 1 hour before exercise, then the resistant exercise is going to carry those RG1 into the exercise skeletal muscle. And you can see that the senescent cell marker decrease relative to the placebo by about 35%, okay? So both studies demonstrate that if you warm up your immune system before exercise, then post-exercise, 24 hours later, you are going to see more senescent cells clearance of your skeletal muscle. Okay, so why this is important? Okay, as I have mentioned earlier, that if your body, all tissues in your body containing senescent cells, those senescent cells is going to trap the immune system. And when you have limited amount of the immune cells that is trapped by the senescent cell in your muscle tissues, then you are going to have little immune power against another challenge, okay? So let's say if you have an infection or you have accident, for example, you have muscle challenge, it will take a longer period of time for you to recover, and simply because your immune system has been used by the senescent cell clearance. Okay, and this is the data. You can see the senescent cell number in the muscle tissues and the phagocyte marker in the muscle tissues are linearly correlated. And this is high correlation, it's 0.86, 84, okay? So that means if your muscle has a lot of cells, senescent cell, then your muscle is also track a lot of phagocytes, and you spare little phagocyte for other things, for example, infection and muscle damage or lung damage, all kind of damage. So now this is the take-home message. Human body is made by age healthy cells and unhealthy cells and healthy cells. Bone marrow supply immune cells for clearing unhealthy cell and stem cell for regenerating the tissues. But keep in mind that the bone marrow are limited. Bone as an organ in your body are limited. So the bone to body ratio, that is the relative bone marrow cell abundance, is crucial for constant renewal, which decreases as we age. So as our body get bigger and bigger, the relative bone mass to the body mass are declining. And that is the reason why the tissues cannot be rejuvenated like the young people. Okay. Age cells, we also call senescent cell, increase baseline information and occupy bone marrow cell, particularly the immune cells, and leave little for others, okay? So the immune cells are very busy on clearing senescent cell and has no time to dealing with like infection, making the cell unhealthy. Okay, exercise eliminates senescent cells and double the tissue stem cells and decreases baseline information, and thus spare immune resource against infection. So the reason why exercise can be beneficial for your immune function is simply because the exercise make your tissues younger, and therefore the younger tissues does not trap the immune system, and you have enough immune system against the infections. Okay. Post-exercise protein supplementation accelerate resolution of information. Immune stimulation by RG1 before exercise enhances exercise-induced senescent cell clearance. Okay, so what is your nutritional strategy for use and the immunity? Okay, first, you want to use the exercise to mobilize bone marrow cells, and you remember the low intensity exercise has little effect. Okay, so you want to have the phagocyte and stem cell get into the circulation and tissues, and when they are in the tissues, you can stimulate the bone marrow-derived immune cells in challenged tissues to enhance the senescent cell clearance, and therefore your body becoming younger. And you want to provide the fast digestible nitrogen and carbon source for cell regeneration. And you know that cell regeneration not only require carbon and nitrogen source, a lot of nutrients are also required. And decreasing senescent cell burden to spare more immune power for defense is the secret why exercise boosts your immunity. Thank you for listening. I would like to thank again for the invitation by American Chamber. Thank you for your time to listen to this lecture.